NASA is going a place where no spacecraft has gone before. Take a look at this.
3, 2, 1, 0. Liftoff of the mighty Delta IV Heavy rocket.
It's headed to the sun. After a 24-hour delay, NASA has launched its first unmanned probe to the sun.
She wished she would have been there with all the thousands of people watching. The Parker Solar Probe is carrying a sensor that will extend beyond the sun's heat shield to get samples of our star's atmosphere. The first download of data back to Earth is expected in early December after reaching its first close approach of the sun in November. It's booking it toward the sun, in other words. Retired NASA astronaut Leroy Child joins us now via Skype from Hong Kong. We always enjoy talking with you about this cool stuff. Leroy, thank you for joining us. And first of all, what an impressive sight, huh? It was a Delta IV Heavy rocket, and it sure looked heavy, didn't it, taking off?
Absolutely. Delta IV Heavy is one of the biggest rockets we have in the arsenal here, and having it launch a probe like this, an important probe, is certainly an exciting event.
Right, and they had to scrub it yesterday, but off it went today. And it's really remarkable that it's going to get there and start sending back data so soon. And I was reading that even though it'll be some 3 million miles still away from the sun, it will be 2,500 degrees Fahrenheit where this space probe will be. How are they doing that? How are they keeping this intact with all that heat?
Right. Well, we're pretty good at building heat shields, so that's going to protect the sensitive electronics inside of the vehicle as well as the other components. But the sensors outside are going to be looking at the corona of the sun, the atmosphere, if you will, and making some unprecedented direct measurements of the solar wind, that is the charged particles streaming away from the sun at supersonic speeds, which was first postulated by Dr. Parker all those years ago, and he was eventually proved right. And so it's neat to see that this probe, which is named after Dr. Parker, who's still alive at the age of 91.
Wow.
Exciting to see us learn more about our star, which is about 4 billion years old and about halfway through its life.
And wonderful that he gets to see this happen. Leroy, question for you. How fast is this thing going?
Oh gosh, I think it's the fastest spacecraft that we've ever launched, and I believe it's somewhere in the 450 million miles, 1,000 miles an hour, something like that.
Wow. We'll believe you. Yes, and I think when it gets there, it will be the fastest moving man-made object ever, going 430,000 miles per hour. I mean, we're
okay, I was close.
It's pretty fast.
What big picture things can we learn about star formation? What will they be looking at? This mission, this is going to last several years too, of data.
Right. Right. Well, we're going to be looking mostly at the corona because, that's about as close as we can get without melting the spacecraft. And so, interestingly, the corona is about 300 times hotter than what is defined as the surface of the sun. And so it's kind of a mysterious area. Generally, the farther you get away from an object, the cooler it's going to be. And so hopefully it'll be able to pick up some clues as to what it is about the corona that makes it actually hotter than the defined surface of the sun. So that solar wind, it's going to be making those direct measurements, very exciting stuff, and I'm sure there will be a lot of scientific discoveries that come out of it that we hadn't even anticipated.
That would be so exciting.
Leroy, just briefly, you mentioned solar winds. Remind people around the world the impact of solar winds, on the United States, on many countries around the world, vital,
Sure.
important equipment.
Right, absolutely. So solar wind is they're charged particles streaming away from the sun at supersonic speeds, and of course they impact all the planets in our solar system to varying degrees depending on how far they are away. And in our case, we have a magnetosphere, that is, the Earth has the magnetic field lines, we have the Van Allen belts, and those fields capture most of the charged particle radiation coming from the sun, which is why life and our atmosphere is able to flourish on the Earth. So very important stuff, and it's very exciting that this probe is going to teach us a lot more about those solar particles.